Well, good evening. Welcome to the November-December issue of FAA Safety Briefing Live. I'm Paul Prydecker and joined by Susan Parson. How are you tonight, Susan?
I'm good. How are you, Paul?
Doing great. As we've discussed before, FAA Safety Briefing is one of the main resources for non-commercial general aviation. And what are your purposes?
Well, it's right here on the slide to raise awareness of resources, explain safety and regulatory issues. But I think one of the most important things for most of us, and certainly for you and me, is to encourage continued training.
Well, we're always in training. In fact, every time I finish a flight, I look back and I think, well, I could have done this better, or I could have done that better, or maybe my communication with my crew member could have been a little different. So there's always something to learn. And over the past couple of days, I've been moderating a few sessions in another industry conference, which was the Global Aviation Training and Simulation Conference. I used to moderate it live in Orlando when it was called WATS, the World Aviation Training Symposium, but it was, of course, delayed until next year. But nonetheless, they put together a virtual program. And the topic that kept surfacing in some of the discussions in the meetings was how is the current situation with our health crisis changed the way we all work. And certainly there's some significant differences in how people are working, especially in delivering training, certainly more online rather than in person or in class. But what about you and your team with the work group to put together this magazine? Is this new business for you, or were you already used to it?
A little bit of both. We have, the FAA has kind of embraced, and especially flight standards for some time now, has embraced the idea of what we call a distributed workforce. I
heard that term yesterday.
I really dislike the term remote because I think it says the wrong things. It's really that we have expertise all over the place, and technology allows us to get to the right person for the right thing, not just who happens to be sitting in the next cube or the next office over. So with the magazine staff, we have been trying for some time to have, we always try to have our planning meetings, in person wherever possible. When I moved to Arizona, that became a little less practical, unless I happened to be in town. But I think we were all set up to go virtual, and that's certainly what we've been doing. Like everybody else, we have Zoom meetings, we have planning sessions. We work electronically. We're using the FAA is going to Microsoft Teams, so we're using that for a lot of our planning and editing and collaboration. So it's kind of like everybody else. Speaking for myself anyway, I'm going to be glad to see 2020 out the door.
Sure.
And hopefully we will have opportunities to do not just virtual next year, but I think we're certainly equipped and ready to keep going as long as we need to.
I think I heard you once say that you're feeling consumed by all the meetings. So.
Yeah, I've heard the term consumed, zombies.
Yeah.
But I think we've all discovered that working online is quite intense.
Indeed, because you're more obligated to pay attention to everything because there we are. So yeah. Right. So what about next year? As we move into next year, I mean, FAA Safety Briefing will continue. FAA Safety Briefing Live will continue. Is there anything new on the horizon?
Well, we don't necessarily. We don't have anything planned in terms of major changes, but I would certainly. I would never rule anything out, simply because as things change, we look periodically at our design, and we look periodically at what are the issues and topics and themes we cover, but also from time to time we swap out departments. We've added drone debrief, we've dropped some other things that over time we didn't need. So we always want to be, just as we are in aviation, we want to be open to changing when it is appropriate to do that.
It makes sense. I think that's true of any organization these days. So
hope so.
So let's get into our topic, which is the short version is CFIT, Controlled Flight into Terrain. And why did you choose this?
Well, it's a funny thing. We all hear about CFIT a lot, and there's a reason for that. And I think until we really got into working on this issue, I knew that it was a continuing problem in aviation, not just in general aviation either,
Certainly
for the on the air transportation side. I knew that it was a problem, but I didn't realize quite how persistent and how big it was quantitatively until we got into this issue. So what we're hoping to do is to talk about, well, first of all, identify the problems, identify some of the causes, and talk about some of the ways that pilots can avoid getting into situations that could lead to CFIT. So that's the idea.
And as you can see, the features articles from the ground up, look out, so things don't go bump in the flight.
Mm-hmm.
Trust but verify. Extra eyes in the sky, and are we there yet?
Yeah, I will say, before we get into it, the rough structure of this has been to outline what the issue is, but we decided to explore the topic from the point of view of VFR, VFR at night, IFR, and then look at some of the technologies, and then also some of the other pressures that come into play sometimes in CFIT accidents.
Sure. So let's go.
Ready?
The first column is by Rick Domingo, and it's entitled "A C to Avoid."
Yeah, that was a little bit of a play on the see and avoid idea.
Yeah,
you could guess.
And some of the key things that are present in here is that this is mostly VFR event, and half of the CFIT accidents are fatalities. And
which is high.
It is high, and there are some identifiable causes.
Well, there are. It commonly, and there are places where it commonly occurs. We have something like in a typical year, there are about 40 of these accidents, which I didn't realize how high some of the numbers were until we started looking. But it's loss of situational awareness seems to be a huge factor. Yes, there are equipment malfunctions. It turns out that automation is a common theme, either not understanding it or blindly trusting it.
Or getting distracted by
it, which is one of the things that happened. But one of the points made here in this tee up to the issue is that nothing can fully compensate when the pilot does not plan carefully and stay alert throughout the flight. That's probably true for a lot of accidents, but it certainly seems to be a common thread in accidents that result in or that become CFIT.
Well, and other causes that are outlined in this article are certainly malfunctions or possibility, limitations in our own performance, fatigue, sickness, things like that, and also limitations in the aircraft performance, primarily discussing things like density, altitude.
Oh, yeah.
I became aware of an accident that occurred in Colorado not too long ago in a single-engine aircraft that had a flight into terrain. And although it's still open for investigation, it hit home a little bit because I knew the individual. I worked with him on an industry committee a few years ago, and then he went on to one of the major airlines. And you think to yourself, okay, this is a well-trained individual. He's in WMC, and this happens. And of course, in this particular event, both occupants were killed. And you sometimes I think what happens is pilots are a bit incredulous that how can that possibly happen, and it wouldn't happen to me. But as I've often said before, the mistakes of others or the mistakes that we make ourselves should really be gifts of learning and lessons, so that we can learn from these things, so that we don't do it ourselves.
Well, I think I learned from you. I borrowed it from you, or I stole it, whichever.
Yeah.
The never waste a mistake.
Never waste a mistake. That's correct. I mean, for me, we all make small mistakes, and through our actions and awareness, we try to prevent them from becoming errors. But there's something to learn on every flight. And again, the lessons that we learn from reading about incidents or accidents or gifts that we should, again, incorporate into our own training and remember what those lessons actually are. You mentioned about automation, and we'll talk about that a little bit later. But what I've noticed is as automation becomes more complex, it's more difficult to understand why it's not working correctly.
Well, exactly. The thing is that automation really does not and I know this may not be, it's not, people like to say that automation reduces the workload. What it actually does is it just changes
Well, it shifts the workload.
It shifts it.
Yeah.
So you may not be manually controlling the airplane, but you might have a lot more tasks to do than you otherwise would.
I'm a huge fan of automation. I use it as much as I can, but again, the general press sometimes talk about over-reliance on automation. And again, if you don't know what to do when it's not working, or you let it become a distraction, then automation is not an asset. It becomes a hindrance. So
which is why I turn it off.
Yeah,
but we'll get into that.
Sure. Our next article is the section on condition inspection, which is well, medically related, and it's about mitigating the hazards of visual illusions, which
spatial. We talked about spatial disorientation in a previous column, one of the condition inspections, but this is visual illusions, which can sometimes be a factor in CFIT accidents. The too high, too low, too far, and I know that sometimes in ground school, when I taught this stuff, the names of the illusions, sometimes they can be hard to remember, and so on. But I think more important than being able to spout, this means that illusion and the name of it, we need to be familiar with the fact that, okay, am I really seeing what I think I'm seeing? If you have water on the windscreen, then that can have an effect. And certainly entry into fog, the whole pitching up, or, and if you think you're pitching up, you might do the wrong thing.
And not to mention night flight.
Night flying, we talk about that in a specific article a bit later, but what can you do about it? And this will be a thread that you'll see throughout the pieces in the magazine, that if you are instrument rated, make sure you're proficient. If you're not instrument rated, maybe that's something to consider. But this is situational awareness and planning are huge. Evaluate the potential before you go. Look at the configuration, of the runway, the conditions, and nowadays we have apps, we have simulation tools that are right on the phone or the iPad, so you can go and try it out. And then there's the good old-fashioned VASI or PAPI to make sure that you're right where you're supposed to be.
Well, and you bring up a good point, which again it's a recurring theme, and that is situational awareness is key to everything here. And it can all start with how you do your pre-flight and how you do your planning, and making sure even something, I see a regulation quoted here, which is one we should all know, 91-103, review all available information prior to flight, but consider more than just fuel, runways, and weather. Even something as simple as having a look at the runway at your destination airport, and you can see by looking at the charts, if you're looking into the appropriate documents, you can see, well, there's a slope.
Exactly.
There's a significant, upslope or downslope, and if you happen to be approaching that at night, that will give you a clue that you need to be aware of what could happen.
Exactly. Well, and I'm a big fan of the apps that are available now. I use one that allows you to actually go and you can pre-fly the approach into the airport and look at it. And at least if you have some idea of what it's supposed to look like and what's around. There are airports that I've flown into where there are little mountains and little obstacles that just are awfully close to the runway. So you have to make sure that you're...
And as you said, the simulation tools that we have available to us are great. There's nothing like doing it for real, but if you know a little bit about what to expect, then you're a step ahead.
So there are two things. One is if you've never been there before, that's a great idea to check it out. But if you have been there before, especially if you've been there multiple times, the issue to be concerned about is complacency. Don't think, oh, well, I've done this 1,000 times, I got this.
Well, and that's true in all operations. I mean, for general aviation, where we may go to the same airport because it happens to be our favorite place for lunch or whatever. Certainly in the airline world, where you're going to the same airports back and forth on a general basis, it's easy to say, been there, done that. But
I need to worry about that. I got this one.
But we can be surprised.
Yeah.
For sure. And the next article is from your colleague, Tom Hoffman, about From the Ground Up, and it talks a lot about some of the working groups.
Well, this is kind of our umbrella piece to talk about what it is that the FAA and the the aviation community are trying to do about CFIT. It turns out, as you see right here at the top, CFIT is third on the list of causal factors. We've certainly talked about loss of control. Power plant failures, I actually didn't realize that was second. But the fact that we're still smashing airplanes into terrain is pretty significant. So what the GA Joint Steering Committee is a government industry group, and it is designed to find ways to first identify causes of common accidents and do something about them. So they set up a working group that spent some time reviewing the data, and this piece describes what they did. They saw and ranked accidents and came up with intervention strategies. And one of the things that they're trying to do is not just technologies and do this or do that, but really shift the culture into some of the things we were talking about before, the planning and situational awareness, plus some really cool technologies that are coming along. But a friend of mine was actually on this working group, and she's flying Alaska, and she talked about how so much of this was personal to her because she knew people who had been affected and who had died in accidents.
I think
like
the number
this.
was 17.
Yep.
It's a huge number.
And that in many of the accidents, and I think this is true for all pilots, or at least I actually hope it is, because we should be humble and enough to say, that could have been me. I could have done that.
Well, in fact, your colleague Tom Hoffman says the humbling part of CFIT is that it can happen to anyone, anytime, and in any kind of terrain. And he starts his article out with a bit of a story about just a normal flight in a single-engine airplane. The pilot had exceptional amount of flight time, I think 53,000 hours, and had a CFIT event. And the NTSB said rising terrain darkness, pilot's loss of situational awareness, and ATC failure to issue terrain-related safety alert. But that's another issue about we should not necessarily feel comfort because ATC is talking to us.
Right.
We're in charge.
We're in charge, and we're the ones who are going to pay the price, have the consequences. Indeed.
The other thing that Tom talked about was some of the safety enhancements, and he has another article in here which talks a little bit more specifically about what those are.
Yeah, we'll talk about those. I actually think that might be in the checklist column. So this this was our VFR piece. And as you see, there's some common themes in all the articles. Be proactive, plan ahead, know what you're getting into, know what your capabilities are, but also understanding the aircraft performance. Density, altitude is a big thing. Another theme, technology can help, but you have to understand how it works. And then there's the good old-fashioned thing that I always recommend people look at. Whether you're using an electronic chart or a paper one, which do you use? Both?
Well, I have a bit of a story about that. I mean, the flying I do for a medical transport company in a Learjet, and I have all of my flight planning I do on a very popular flight planning app on the iPad. And this app has all of the IFR charts. It has the high altitude en route. It has the low altitude en route charts. But that's not actually what I use when I'm actually flying. When I'm actually flying and we've done all of our planning and we're en route, I have a sectional out on the
that's what I was asking
on the app. Is I actually have a sectional, partly because I like to look down on the ground and say, oh, I recognize that place, or what is that place? However, if you should well know that IFR en route charts don't have any substantial terrain information on them.
Exactly.
And I am frequently flying into airports that I've never been to before. I may never go back, but I have displayed a plain old VFR sectional chart just to maintain awareness of what's going on down low.
And that's a good idea. And another thing is part of your planning, but also as part of your flight monitoring. And you'll see this on the first bullet on the upper right-hand side. look at VFR charts for the minimum safe altitude and for the maximum, the MEF figures, maximum elevation figures, because in the grid squares, they will show you what the highest terrain or man-made or obstacle.
And you might have to search within that grid to find where that is, but at least it gives you a starting point of safety.
And if at least I'm this high, then I shouldn't hit anything. And then Google Earth, I've been using Google Earth for a long time to go check out terrain and have a look and say, oh, what does this look like? And nowadays, again, you can use apps to zip right in and almost as if you were there. Really
indeed. Fun. And the point on the right about understand density altitude.
Yes.
This is something that I've seen a number of times, certainly in piston aircraft, that you may go to an airport like Denver or the Denver area airports, and your aircraft is a different aircraft. It doesn't have the climb rate that it did in the Midwest, and it becomes a runway hog because of density altitude. But guess what? The Learjet does the same. We are often looking at our legal numbers for takeoff based on temperature and altitude. And even though we're in a jet aircraft, I'm often surprised when I see the 8,000 foot marker go by, and we're just and we're just now getting off the ground.
It gets your attention.
It does. It's something that it's part of our planning. It's something that needs to be understood and certainly respected, but it's all part of situational awareness.
Yeah, the last bullet on here, I was actually surprised to learn that power lines and supporting structures were another of the CFIT hazards for fixed wing CFIT. I knew that was an issue for rotorcraft, but I was a little surprised to see it mentioned in this piece. But, towers, power lines, all sorts of things can be marked.
What's your memory aid for towers?
Oh, yeah, for towers, there are two, when you're looking at the charts, there are two numbers on the chart. And in ground school, I was taught about that. The number on the top is what the altimeter is going to say if you hit it. And the number on the bottom is how far you're going to fall after you've hit it. So there's a little grim,
but it's a good way to remember it.
Nobody ever forgot that.
Yeah, so, indeed. Okay.
Hopefully they paid attention when they were actually flying.
So things don't go bump in the
night? Yes.
Okay.
Yeah, playing with the Scottish poem, of course, of things that go bump in the night. Yeah, this VFR at night, and I remember reading a while back, I was a little, it doesn't surprise me, but it's actually the surprising thing that we in the U.S., we are allowed to fly VFR at night.
In some countries,
there are countries that do not permit that simply because avoiding terrain at night is harder to do. And I can tell you the first few times that I was flying in my home airspace, there are some little mountains around there, and gosh, I mean, they're just plain as day during the daylight. But I can remember the first time I came back into the airport at night, looking down saying, whoa, it's very dark down there. I know that there are little hills, but gosh, I can't see them at all. So this is where those MEFs are awfully important, and know what kind of a margin you have. This piece starts off with a story about an accident that I think I knew that one of the people who was involved in it, and it was a case where there was an over-reliance on automation. Then night is the time for spatial sensory conflicts, spatial disorientation,
Certainly.
like we talked about. And it says about 10% of GA accidents can be attributed to that. So that's another piece here. So there, Paul, it talks about various things that you can do, and one of them is using IFR practices if you're rated.
So I'm a big advocate of everybody should have an instrument rating, because it'll make you a better VFR pilot as well. And this is one of the reasons. If you're familiar with instrument approach procedures, you can use them on a VFR flight, and working with an instructor to help you understand the basics of some of the ground-based and GPS will really help. I often tell the story about years ago in my airline career, we had changed our operation and started flying more onto the East Coast. And we were based in Philadelphia. And it was common knowledge that we were going to land primarily on runway 26, if the winds were appropriate for that. We were going to land on runway 26 because it was a shorter taxi to our gate. And it was also a shorter runway. However, it didn't have an ILS that we could use because of our category certification. Right next to it was 27 right, and yet another runway 27 left. And the first time I went in there was at night. And I mentioned to my first officer, I said, I know based on what's going on, they're going to offer up a visual approach to 26. He said, yeah, that's what we do here. And I said, well, let's just avoid all the drama. I'd like to request an ILS to 27 right. And he said, well, why? And I said, never have really even seen the airport during the day. So I don't want to try to do a visual approach at night. Now, could I? Of course I could. But as a matter of risk mitigation, if I flew an ILS down to 27 right, I know I'm going to get to the runway. And then the next day when I look around at the airport, I can see what 26 really looks like, because on about a 2-mile funnel or some cranes and things that are part of the shipping docks there that you have to fly over. So it's just one of these things. Did it take a little extra time? Yes. Was I glad I did it? Absolutely.
Well, it's if you are instrument rated and you're going into an airport, you could certainly request the instrument approach. There's no reason why you couldn't, especially at night. And if it's an airport that has an instrument approach, particularly with vertical guidance of some kind, even if you're not talking to ATC, if you want to try to tune that in and follow it.
Sure.
And always PAPI, VASI, all those things for cruising. I thought, it was a good reminder to make sure that you choose a cruising altitude that provides the kind of terrain separation. And the recommendation is 2,000 feet in mountainous areas, 1,000 feet elsewhere. And another piece, and I know about this. I know it's not necessarily practical for everybody, but supplemental oxygen for flights above 5,000 feet, because it really does affect your vision. And nowadays I have a watch that does the blood oxygen thing. I guess it's not. I check it periodically just to see how I'm doing.
The other thing too that's important in all this, and it's basic to our flying, but it's sometimes overlooked, and that is to remember, if you fly across the front, there could be a significant change in pressure to where your altimeter setting is going to change.
And that's a CFIT issue too, absolutely.
Especially if you're at night. You need to pay attention, and which is why the recommendation is to get a frequent altimeter setting. So I think the other part of this is kind of a general practice I have, is that if I'm flying to an airport for the first time at night, I will not accept a visual. I'll always do some sort of an approach, just so I have a better feeling about getting
there. And that's
there.
a great way to make sure that you don't get into terrain when you are still in controlled flight.
Sure. This is an expression I heard in, I think, 1980.
Oh, trust but verify. Yeah, I've used it a lot since then. So this piece, when I was learning to fly, when I was training for my instrument rating, but also when I've taught, I've always found it interesting that I don't think that there's enough emphasis on obstacle departure procedures. Most people know what SIDs are, and SIDs may have an obstacle clearance function, as we talk about here, but it's entirely possible. In fact, many SIDs exist for ATC efficiency purposes. But a SID, a standard instrument departure, will be part of your clearance. However, an obstacle departure procedure is not going to be necessarily part of your clearance. It doesn't have to be requested. It doesn't have to be assigned. It can be flown without clearance. And that's just not something that I think is well enough understood, because when you're training for instruments, it kind of gets drilled into your head. Don't fly, you fly your clearance, fly your clearance, fly your clearance. And I think where this really came home to me, when I lived on the East Coast, there was an airport I used to fly into periodically, and if you're departing, it's a non-towered field, so you had to call a distant facility, and they would say, upon reaching controlled airspace, do this, this, and this. But it was always direct to a VFR, to a VOR, which had mountain in its title. There was a reason for that. It was on top of a mountain.
Mhm.
And if your aircraft couldn't make the climb gradient and you departed and went straight for it, you might not get to the correct altitude in time. So there was an obstacle departure procedure, and I always used it, especially if I was departing in instrument conditions, so I couldn't see anything. And the ODP involved just basically taking off and circling above the airport until you got to the right altitude. So when I taught, I always would say, I always try to teach people, if you are not comfortable, first of all, you can always put in the remarks section of your flight plan that you intend to use the ODP. And then when I got my clearance, I would always say, be advised, I plan to use the ODP on departure. Oh, thanks, sure. So but make sure that you know that it exists and you familiarize yourself with it before you depart an IMC, even if you think you know where you are, because you might not think.
Absolutely.
Yeah, it's not, it's never a bad idea to do that.
Well, and this is covered very well in the AIM 5.2.9, but then you also, in this article, have a very nice chart that summarizes the differences and similarities between SIDS and ODPs. So it's good reading.
Well, yeah, the chart was to try to just summarize it a little bit for everybody, but also to remind people that there are other things that we need to be familiar with, because every time the AIM comes out, there's all sorts of new procedures and new information because the technologies keep changing. But diverse vector areas, visual climb over the airport, know where to find these things in the terminal procedures publication. Another thing about instrument flying is make sure that when you're doing the missed approach procedure, you know exactly what you need to do to avoid terrain, because a missed approach can be a major opportunity for CFIT.
Well, and in the aircraft that we typically fly in general aviation, especially as we move into the light twins, if you're anticipating flying an approach to an airport in your single engine, a careful review of the single engine, or a careful review of the missed approach procedure, you really have to pay attention to, because you will not have the performance that you think you do. So having a thought about what the airport beyond, or what the terrain is beyond the airport, and how we'll be in single engine and a twin engine airplane affect that is huge.
Well,
it also, I think what it gets to is, if you're shooting an approach because you need the approach to get down, is there another airport that might be better suited for that?
Yes.
It's not always the case, but it's something to think about.
And the last point that I think is really worth making in this context is, this is another place where automation, knowing what your automation is going to do. There are autopilots and navigators that will give you course guidance, but make sure that you know what it is and that you know where it's taking you. Don't just simply rely on the airplane to take you to a safe place. You need you've got to pay attention.
This was sort of a fun one, extra eyes in the sky, more about technology.
Yeah, so this was part of our setup. We wanted to do the umbrella piece about why do we care? Why is this an issue? Why are we bothering to devote an issue to this? And then we talked about CFIT and VFR and night VFR, and then in instrument conditions on IFR. And then we really wanted to get into what some of the new technologies are. Now, you may or may not have some of these, and they're all explained in terms of what it is, and some of the costs and currency requirements and everything else. But I really like the way James set it up with these are all superpowers.
Well, we have enhanced vision systems, which uses sensors to give you a look ahead, and then synthetic vision, which is less costly and is its technology is completely different. And I have some experience. Our friend Mike, in his Bonanza, he has synthetic vision as part of his avionics suite.
Oh, wow, I'm jealous.
And it's really amazing at what it can project on your primary flight display. However, it's one of these things, again, that and this is not directly related to terrain avoidance, it's more related to judgment, situational awareness. Just because your synthetic vision can display the stripes on the runway does not mean you can go and do a 0-0 takeoff.
Oh, that's crazy.
I mean, yes, you can under Part 91, should you. And the more you have tools that allow things like that, the more you have to apply your judgment and say, I'm not going to do that.
Well, this article too, so it's set up talking about the X-ray vision, that's the Superman superpower, and EVS and EFVS. So there are a lot of letters and acronyms in these things. But one of the things I learned from reading this is a point about synthetic vision that if you think about it, it makes sense. But if you're not paying attention, because it can look so realistic that you really do think that you're seeing exactly what's out there. But synthetic vision, and this is the point made in the last bullet on the left-hand side, it's showing you what should be there, not what actually is there. So if there are traffic, vehicles, wildlife, or something on the runway,
that's right.
You're not going to see that with a synthetic
and plus,
vision.
You're at the mercy of the correct databases.
You're at the mercy of a lot of things. Sure. Now, with the next one was Spidey Sense from TAWS, or terrain avoidance. And these days, when you fly with the G1000 or any of those, where you put up the terrain, you can see when it's all red and everything else. So you have lots of information.
Well, even on tablets.
Oh yeah, exactly.
Some of the apps are having that.
Yeah, and they start yelling at you, terrain. Now, then another one is Iron Man and the Jarvis, which I didn't realize what Jarvis stood for until I read the article. But you can read it to find out what that acronym stands for. It's very clever. But it's about artificial intelligence, and this is an idea that's starting to come up with the digital co-pilot and give the pilot information. But I think, Paul, that one of the most important pieces that we want to stress again is that last bullet.
Situational awareness.
Well, yeah, and
responsibility.
I love the way that it was framed in the piece was. You have to know the limitations that with great power becomes great responsibility.
It's a great line.
I know. Yeah. I thought it too. And that if you push your powers too far, they could put you in exactly the situation that they were intended to avoid. So superpowers are great, but superpowers carry super responsibilities.
Indeed. This next one is something that I think we've all dealt with at one time or another, and that is, are we there yet to get home their itis? It's built into pilots, I think, to be mission-oriented, to complete the mission, do it right. One thing that came to mind was when we're planning a flight, direct does not have to be the route. I mean, we could do something different and still get there. But the pressure we get from passengers and perhaps our coworkers needs to be regarded as a threat to safe operations so that we don't go into inadvertent weather or continue the flight into night. So there are some mitigations, SOPs and call-outs, and just briefing your passengers.
Well, that's a big thing, was to managing passenger expectations early. And this piece interviews some FAA people who talk about the fact that, they do what I always have tried to do too, is manage the expectations, not just of the passengers, but also the people who are meeting you on the ground.
Sure.
To just do whatever you can do, because pressure leads to distraction, and distraction or pushing your limits, the VFR into IMC, those are the sorts of things that are often factors in CFIT accidents. So a CFIT avoidance issue would not be complete without talking about the dangers of external pressures.
One of the bullets is about the medical ambulance helicopter.
Yes.
And the author discusses that example that it's common practice that the medical crew does not tell the pilot what the condition of the patient is that he's picking up, so that he doesn't get some bias built in.
Must go, yeah, exactly.
So that's a good mitigation as well. But I think proper briefings and expectations and managing expectations is important. And not just with passengers, it can be with fellow pilots and just yourself.
Oh,
You have to manage your own expectations sometimes. So believe this is yours. Don't hit the dirt.
Don't hit the dirt. Yeah,
Yeah.
the purpose of the checklist column is to talk about what FAA resources exist. And so it turns out we certainly have advisory circulars, general aviation, control flight, and terrain awareness.
I noticed that it came out in 2003.
I noticed that too. And I looked to see if there was a more recent issue, and there's not. And that's actually kind of a sad thing, because the fact that the same issues and the same mitigations, some of the same mitigations are still out there, means that we haven't made the kind of progress that we would like to. But this AC looks at 3 broad categories, VFR and IC, but it has safety recommendations. And one of the things I liked about it is it includes a copy of the Flight Safety Foundation's CFIT risk assessment tool. The other thing, it's not mentioned as much on the slide here, but the gray box at the bottom of the article includes links to some of the resources, which include videos. And there's one specifically that's listed here, which is an FAA video about CFIT avoidance. But oh my goodness, if you look on YouTube or so many places, there are all kinds of resources that talk about, here's what I almost did, don't do this, or here's how not to do it. So if you have plenty of resources for CFIT avoidance techniques and tips.
Our drone column is about motion parallax effects in aerial photography. But even before that, drones can have these events as well.
Yeah, I mean,
the operator needs to be aware of that, and I'm sure most
right.
are. But everything we've been talking about is in terms of situational awareness and planning has to apply to this as well.
It absolutely applies to this as well. So we try to, when we're planning the issue, we reach out to the people who write the different columns and say, hey, this is the theme. Do you have anything that's going to be appropriate for this theme? And, if they don't, they don't. But CFIT, it turns out, is an issue for everybody, including drone pilots. Drone pilots, obviously, they don't want to hurt anybody by running the drone into something or hurt property. But some of the drones are pretty pricey, and if you want to make sure that you don't mess up your gadget, there are all sorts of things to be aware of. And this one gets into how to use these techniques not just to save your drone, but also to
how to be a better
photographer using your drone. So I learned a lot.
Well, it talks about monocular cues like motion parallax and perspective and things like that. And I'm imagining if I were trying to follow a drone several hundred feet from me, things wouldn't be as easy to determine. I mean, our depth and our judgment and our ability to recognize things is a little bit different. But this author goes into how you can demonstrate some of these with the video set up. And for people who are using these for their business, this is a very important article to make sure you're getting the most out of it. And as you said, be better at the photography and to also understand the planning that goes into it.
Because visual illusions can be as much an issue for this as they are with for human pilots, just in a different way. But I think there are also some tips and techniques in there about when I am starting to learn a drone, here's what I do to make sure that I don't hit anything with it.
Exactly. On our maintenance column, that's bolts and electrons. We're talking here about
safety wire.
Safety wire.
You remember that?
I do remember safety wire.
When you were building an airplane.
Trying to build an airplane, safety wire was a factor. Learning about, a lot about nuts and bolts, actually. Literally. But when I was looking at this, I mean, it's a very good article, and there's an advisory circular listed at the bottom. 4313-1B outlines the various locking methods and proper safety wiring procedures. They talk about, we have cap screws, we have cotter pins, we have self-locking nuts, and safety wire. And the main message was if a bolt has a hole through the head of it, there's probably a safety wire is needed. And there's quite a lot of discussion that this is not something that you just wrap a wire through and twist it and call it good. There are specific techniques. What I came away with is that how important knowledge of this is for your pre-flight or post-flight.
Yes.
I usually tell people, when you're walking up to your airplane, you do kind of a macro look.
Exactly.
Is there a fuel truck behind me? Is it tied down? Right. What about the chocks? Overall condition of the big picture.
Big picture, then little picture.
But there is a lot of little picture things.
Yes.
I mean, how many of us have stood there looking as we're maneuvering the elevator up and down, and we see a cotter pin in these bolts, and missing ones need to be addressed.
Absolutely.
And to the extent that you can see fastening hardware in the engine compartment when you're doing your pre-flight inspection, you need to know where some of these where bolts that may require safety wire are. So I found this to be just a fun sort of, here's what you look for, here's what you need to know. And for those people who do their own maintenance, grab the advisory circular if you don't already have it, and it'll give you some good information.
There's an advisory circular for everything, if not more than one thing.
It seems to be. Again, your colleague Tom Hoffman, seeing fit to end CFIT.
Yes, we have fun with titles. Yeah, this one is the piece that describes some of the safety enhancements that the GA Joint Steering Committee came up with to try to address CFIT. And they came up with quite a few, but there are 6 that are currently being implemented, and they're listed here. There's augmented visual technology, and we already talked a little bit about EVS and SVS, synthetic vision. Mm-hmm. Another thing is using overhauling the wings platform to include CFIT. Looking at what we talked about earlier too, with some of the cultural issues that come into play here. The pressure to complete a mission, using technology, using approach guidance, and then weather technologies. And
the other one that's interested is unintended flight into IMC, or they call it UIMC. Somewhere else in the magazine, I think it might have been your colleague Karen had contributed something to that, to say that if you talk about what's the escape strategy for inadvertent flight into IMC, the most common response is, well, turn around.
Doing that 180, not necessarily.
But she pointed out that maybe that's not exactly the right procedure, depending on what's actually behind you, that it may be climb or do something different. But again, in order to do that, you have to have knowledge of the terrain around you as well as the weather. And
what your aircraft can do and what you can do.
Exactly.
So it's a lot of it comes down to, they're not simple, oh, just do this. And so much of it is about what we've been stressing, planning and situational awareness.
Absolutely. For our helicopter gang, this is...
That's it, wire strikes.
Wire strikes.
We talked about that a little bit earlier, but here's where
it's certainly an issue for fixed wing, but especially for the rotor wing operations. Because of the nature of the operation, often down low, maybe at night. And how is the industry trying to mitigate
this? And the fact that they've done a lot of studies, and people think, oh, well, I'll see this, but they don't. There are too many winds and wires that simply are not seen before it's too late. But it was interesting to me that this is being seen not just as the pilots need to do better, that there are a lot of companies that employ these pilots who are expanding their training, not just to pilots, but also to utility crews. And they're trying to help enhance pilot understanding of the structures and the hardware. Mm-hmm. And so it's a little bit more what to look at. And then there's wire environment training with basic information, and then human performance, helping people recognize those personal biases that can lead them to think, oh, it can't happen to me, but in fact it does.
Well, and there's another tip in here that says, here's some tips on mitigation. I mean, some of the obvious ones: avoid low-level flight, of course, become familiar, but brief all crew and passengers to speak up.
Oh yeah. Well, that's the same thing as we do with traffic. Speak up if you it should be part of your briefing to passengers. If you see something that I should know about, speak up.
And this last bullet point, assume that wires are always present in some unfamiliar area.
Yes.
So it so often happens is we talk about the rotorcraft industry and rotorcraft operations, all of the good advice that applies to their operations applies to fixed wing operations as well. But of course, this is an especially
a bigger problem in this case.
Certainly a bigger problem because of their abilities and their
the nature of the operating environment for rotorcraft.
Yeah, absolutely. So I know this is yours because of the title, Automation a la Mode.
Yeah, this is about mode awareness. So I wanted to really address the fact that automation is a double-edged sword, and that we have an unprecedented level of situational awareness, and we may even have it yelling at us. But you still got to see it, and you got to hear it, and you got to be paying attention. There is no substitute for paying attention. So I like to use the phrase that PIC can mean pilot in command, but it can also mean passenger in comfort, or passenger in complacency, which is also the case. Pilot in complacency is the worst. And that what can you do with situational awareness? Do whatever you can to keep your own brain in the loop, and that means call outs, that means verbally announcing what modes your autopilot is in. And I like not just call outs, but also recording things in writing, because running something through your brain in different ways is a way to make sure that you know that it's going to sink in.
Well, you all know that I've been a proponent of and have written a little bit about trying to create flight profiles in general aviation. And a profile is nothing more than a graphical representation of triggers and actions along a timeline in various phases of flight. And you can make your own. If we just take, for example, an instrument approach, where you put the gear down, where you extend the flaps, can all be set and established by a profile that you've established for yourself. But built into that can be call-outs.
And there should be.
And the common ones. You're crossing the final approach fix at a certain altitude, which is also on your chart. So that's an instant comparison to make sure that everything is synced up. But things like 1,000 feet to minimums, 500, 100 feet to minimums, these are all typical call-outs that are in the Part 121 and Part 135 world, and we can absolutely apply them in our general aviation environment, making sure automation is doing what we think it is.
And so that's one of the reasons that one of my standard practices too is to read the status displays aloud when there's a change and say, this is engaged, this is armed. Whoops.
Yes. Yep.
Oh, I think I accidentally took us a little bit too far. But
that's all right. We'll go back.
There we go. That's what I get for letting my hand hit the mouse. Yeah, I think we pretty much covered everything that was there, but it's all about paying attention.
Well, indeed. And one of the things that I've noticed too is that when you have a situation where your autopilot or your GPS or whatever your avionics suite is, when it's not doing something that you expect, there really is no time to sit there and think, well, gee, what happened or why not?
Turn it off.
Just get back to flight path management manually and deal with why something slipped out of the FMS flight plan or the GPS flight plan. If something's not acting as expected, I'm really caution people, don't sit there and take too much time to figure it out. Just get a hold of the airplane and then go back later. If you're in a two-person crew, you might have a different response to that. But still, automation that's not working is a distraction.
And don't get lost in the distraction, because it's a good way to hit things you're not supposed to.
Sure.
Actually, you're not supposed to hit anything.
Chad Brewer is FAA Faces this month.
He is, and he was recommended to us by one of his fellow members on the GA Joint Steering Committee of CFIT Working Group. And he has, he has all kinds of experience and background to do it, but his team is the one providing technical expertise and input, and they are the ones who are developing the safety enhancements to prevent CFIT. And he's obviously an advocate for CFIT-related training, but the other thing is, he says, if you see pilots doing something they're not supposed to do, speak up for everybody's benefit.
Well, that's the spirit of being a fast team rep.
Yeah,
Is if you happen to see something, say something. But all of us can. And his work group was one of the ones that put together many of the safety enhancements for this topic. So congratulations to him for being featured. And as we move towards the end here, the November-December ATIS, which is sort of a news roundup. You have a new podcast, which is
it's called the Air Up There.
Mm-hmm.
Easy enough to find, and there's some links in the piece. There's a new display system with LiDO, SAV gas testing, lots of.
And what about the grants for careers?
The FAA, I'll let you read the magazine to see what it's about.
Maybe I could use a career.
Well, I think you've got several going right now, so you're good. But when you're ready for the next one. And
then the other one, which is very important, and again, it's another situational awareness thing. The video about wrong direction takeoffs.
Yeah.
How can that happen? You think to yourself, how can that possibly happen? And it certainly can, especially if you might be doing an intersection takeoff. Certainly, we have some literature that shows when you're doing intersection takeoffs, you might turn the wrong way. But mitigation is easy. Announce what the heading should be when you roll onto the runway. And if you happen to see the numbers on the runway, that's even better. And just confirm that everything makes sense. We wrote about this in another article about TLAR. That looks about right. Well, in a runway, that it has to be right. It doesn't look right. It has to be right.
Precision does count.
Indeed. So feedback. I know you get feedback on the magazine.
We do,
how do people do that?
We publish in forum what we've been hearing. You can reach us at safetybriefing@faa.gov and also on Twitter at FAA Safety Brief. So we have all kinds of ways to talk to you.
And once again, your social media director, Paul Cianciolo, does a great job of keeping all this together.
He's very active in all of this. Absolutely.
And what are the ways we can look at the magazine?
We have the PDF and also several other mobile formats. You can subscribe to the print edition. And as I already mentioned, we're very active on social media. So you can find us in a lot of different places.
Very good. January, February 2021. It'll be a new year for us.
Thank
goodness. New round of FAA Safety Briefing Magazines and FAA Safety Briefing Live, which we will announce the dates later. And do you have advanced knowledge of the topic?
Of course. Challenge and response. And it's not just checklist. We're using challenge and response to talk about getting back into flying and all sorts of pieces.
We appreciate your viewership and your interaction with this program.
We'll see you in January. Happy New Year.
We'll see you in January.